we're going to talk about log file analysis, and probably more than you really ever wanted to know about how to get data out of log files. And so one of the things that both Ethan and I have noticed in our long, many years of looking at log files is it turns into what we call a data addiction. And we are not responsible if you develop any kind of data addiction from this talk. You're on your own. We'll give you some ideas about how you might be able to deal with that data addiction.
This warning is really for those who make it all the way to the end, right?
Yeah, this is warning.
That's the first sign.
Yeah, if you make it to the end, you might have the same kind of problem that we had. I started a long time ago looking at log files, and it blossomed into, I ended up getting a data science degree. And so it can go kind of far. Well,
Yeah,
why? What were you say?
Oh, I just wanted to say Derek is obviously doing incident response, data science degree, this data science masters, right?
Yeah.
I do threat hunting at Black Hills, detection engineering, and I really enjoy data engineering as well. So between the two of us, we process a lot of logs, and that's kind of the
lot of data
inspiration for this talk.
Yeah, I mean, in fact, that's a good segue because log file analysis, for me anyway, and for a lot of places, ends up broadly becoming data analysis. And so, why are we doing this talk? Well, first of all, the community asked for it, and feedback that we got was you all should do content on log file analysis. And so, in the rest of the time going to talk about. We'll have some examples where we're going to talk about kind of broad like categories of techniques that can be applied to any kind of data analysis situation, and really in log files they make up the foundation of incident response. You'll have log files that you'll go after. Then monitoring and alerting, most of you are probably already aware that when you feed data into get monitoring and alerting, you feed data into some kind of centralized location. That's sort of the foundation of your security program. So log files are heavily relied on for most things in information security. And as always, there are challenges to that. Lots of challenges. So
right.
If you went to Ethan and I's talk, what did you say it was in 2021?
Yeah, November 2021.
Seems like it was a lot longer ago than that, but it wasn't. At the time, we did another log file analysis type of talk, looking for needles in a needle stack. And then we kind of had big three sources. It's expanded since then based on, things that have kind of changed in our perception, things that we've been doing. And now I kind of look at it as the big four sources. So you have host-based stuff. So endpoint logs, think Windows log files, or a Linux machine that has, logs flowing into var log syslog or secure or something like that. And then network logs, which is always something that's near and dear to our heart, as you will see soon. Then we break out Active Directory and M365 separate because I think they discreetly need to be handled in different ways. And then we've got all these other sources. Well, that's sort of where a lot of logging challenges come into play, right? Because in some of these, you may end up not being able to consolidate them. You might have to do some more manual analysis. And so where do we get the data that we're going to be analyzing? How do you get the data? There's like two really broad categories that we look at in terms of, acquiring the data. So the first way, which is probably the most common for folks, is you're going to, especially if you're coming into an organization that has some level of maturity, there'll be centralized log points that are going, or log file collection that goes into something typically called a SIM, right? So ideally, you would want all of your logs to go into this centralized collection SIM of some sort. There's a lot of different ones out there. It used to be that SIMs, back in the day, and ancient information security history, also known as 2014, that a lot of organizations that were small and medium sized couldn't really afford SIMs because traditionally they were a half rack of servers that lived in a data center and cost $250,000 to get into the ball game, and it was out of reach for some places. Now there are pay-as-you-go options. Two that I usually recommend to look into if you're looking to consolidate log files would be Sentinel, Log Analytics from Microsoft, or even Elastic. I like Elastic a lot. Sorry, Troy.
Yeah.
I like Elastic.
So, yeah, I wanted to just kind of cover the cases like, hey, you mentioned ideally everything goes to your SIM, but why might that not be the case? So some examples would be, so Derek, coming from incident response, like I made the joke the other day. Well, obviously you should be sending memory dumps on a regular basis to your SIM, right? But no, obviously that's not going to happen. So anytime you have an incident, you're going to want to go out and get logs and artifacts that are tailored to kind of what you're investigating, and things that probably wouldn't be in any centralized data store.
And there's
Another
Oh, go ahead.
another thing that could happen is maybe cost is an issue. You can't store absolutely everything, so there's always going to be something that you're not sending to your SIM, just for practicality, and you may find a need for that later, and you'll have to go out and grab the logs from the endpoint to the server or whatever, and manually analyze those logs, or potentially import them into your SIM ad hoc. And so another case, and we find this all the time too, is sometimes you think you have the logs in your SIM and they're just not being parsed correctly. So the original log is kind of gotten discarded from your SIM, but you still need that information, so you have to go back to the source and find it and analyze it from there.
Yeah, typically what we see with customers is cost to store things, and we face that as well, as you're going to find out later. I'm not going to spoil it, I promise. Cost, size, scale. There's a lots of barriers to centralization that you'll end up facing, and like Ethan was saying, when a lot of times in an incident response scenario, you think of the SIM and centralizing log files. It's sort of like a wide net of trying to casting a wide net to try and detect things, but often you might have to go do tactical acquisition to go and make a deeper dive. There'll be log files you're not ingesting that you might want to look at. And so really, those are the two kind of scenarios that we have. We have incident response cases where you might be getting different data or more data than you're typically used to looking at. You might have to manually parse it. And that kind of goal, there's usually like a pivot point or something that you'll start with in the log files, and then move from there. And the goal is usually to answer some kind of question. So that's one grouping of log file analysis that we kind of keep separate in our mind. And then the other thing is going off and looking for bad stuff that we didn't already know about, aka threat hunting, aka farting around on the network, whatever you want to call it, where you're going to try and go and take log files as a whole and make some kind of sense out of that. Now, even though these are two discrete cases, you're really going to be using kind of the same approaches when you're analyzing data. And so this is one of my favorite slides. It seems to end up in a lot of the presentations that I do. And that's a model on how we detect things. I don't mean just detecting like for monitoring and alerting, but detecting something in a log file or finding something that you want to, like a question of interest. And so as we move forward through the slides, keep in mind what this funnel was telling us. So we basically have all of this raw data that is across your computing environment on various systems, typically in log files. It could be other formats. And then there's, most of it is normally produced. It's being produced on this machine, or on all of your systems on these machines. And then somehow you need to apply some kind of techniques to kind of filter down that data and do detection and analysis type work. And it ends up, volume wise, probably being less than 1.5% of the data that you're after when you have a question of interest or you're threat hunting. And then, so you'll apply techniques to do the detection and analysis. We're going to talk about those categories of techniques in a little bit. And then you have what we call domain knowledge. So in data science, domain knowledge is basically your knowledge about the specific domain of information, in this case, information security. And log files, your expertise in that domain, you're going to get to a point, and at the end of detection analysis, where you have to apply that domain knowledge to get rid of another grouping of data and get to that potentially malicious log entry that you're looking for.
The size of your haystack at the beginning matters too. So like we're talking percentages here, but I mean, 0.1% of a billion is still quite a few.
Quite a few, right? And so usually the rule of thumb, what I teach in my class when you're doing log analysis is if you do some kind of, filtering or transform or aggregation, and you have more than say like 100 data points to look at as a human, you might want to filter it more. And you probably get away, just gray area. Like you got 200, fine. You can probably manually look through that stuff. But if you have thousands of lines that you're looking through manually as a human, it's just not the best. It's not the time efficient way to do it. And I would encourage you to do some further filtering and apply more domain knowledge to get it down to something that can be digested by a human in a reasonable amount of time. And I usually define that reasonable amount of time as, an hour or less, right? I think that, you need to be able to kind of, apply these techniques and find that question of interest.
Yeah, absolutely. So when you're threat hunting, for instance, you maybe come up with an initial hypothesis and decide, oh, these are probably the things that I'm going to use to filter down to events of interest. And you might get to the end of your initial hypothesis and realize, oh, there's still way too much data. There's nothing saying that this can't be applied again. Like iterate and come up with new ways to filter the data based on what you're seeing in the results that you do have. Use some of the techniques that we're going to talk about in the next couple slides to keep filtering it down until you get to the most interesting. And that's the tip of the funnel there, the potentially malicious. So what types of techniques could you use? And I think there's probably not anything super new here for anyone, because these are just things that you do all the time.
Without thinking about it, right? Like there's things, you don't even know we call it a name.
Yeah, it's just interesting once you've used a bunch of different SIMs or different technologies, like you do analysis on the command line, in a database with SQL. These techniques translate to all the different systems. They may be called something different. You might do it a slightly different way, but especially on this slide, the fundamental ones, I would say your SIM is probably lacking something if it can't do one of these.
Or can't do it easily, right? Like what's one of those things where you're like, for those of you who are like, that's great, you're telling me how to do a transform at the command line, but when I'm using XYZ, it's hard to do. Yes, I feel your pain. That is definitely, again, not responsible for the data addiction at all. And so these are things that I use every day, right? So locating, filtering, like where's the data? How can I filter data out? What data am I looking for, right? I'm selecting specific things that would be relevant to my question of interest. And the example that we're going to walk through here in a second, I'm going to show exactly what I do at the command line to, walk through an example of how I go find something that's potentially bad. And you might, if you're new at the Linux command line, you might be thinking that aggregating and things like that sounds kind of complicated. Yeah, it can be. And so these are sort of like the fundamental techniques that we rely on, every day. And then there's some more techniques that I might not do it every day, but especially in threat hunting, these or writing detects for catching something. These are, well, I'd say I probably use these every day too. These could all be fundamental too. But these are more essential type techniques. Probably my favorite one, the data stack, right?
Yeah, these are less likely to be just automatically built in. But you should be able to take some of the building blocks from the previous pages to do these. So like data, you're talking about data stacking is really just, it's a combination of you take all your data, you aggregate it in some way. So you're calculating like sums or counts or, some sums or summary statistics, and you stack it, you sort it, you possibly limit it. Especially if you're doing like long tail, short tail analysis, most frequent occurrence, least frequent occurrence. It's all kind of same names for different names for the same thing. The whole point is to find what's either most common or what's rare based on the type of hypothesis you have or thing that you're looking for.
And then pivoting is something, especially in incident response, that is like a key type of technique, right? You're going to find something, an IP address in one log file, and you might think, man, I really need to see who else in the organization communicated with this IP address or domain, or maybe I have a hash and I want to go into a different log source and say, I know this hash is malicious. Is it found here too? So that's another one that happens quite frequently in IR.
So pivoting, I would say, is more likely to be a manual technique in a lot of places. But if you think about it, it's kind of almost the same as joining in like a SQL database. You take two tables and you're pivoting based on the commonalities between them, and you're grabbing information from one data set and then enriching it with data from another, and it's kind of the same idea. So in some cases, especially databases, you'll be able to do this in an automated fashion, and that makes life a lot easier.
And then in some cases with SQL, you're like, wait, is this a left join or right join, an inner join?
There's so
what
many
kind of join
joins.
is this?
Yeah.
It's funny how, sometimes think like, my kid asks me, when am I ever going to use this in life? Mostly about algebra and geometry, right? And I sometimes think thought the same thing of like in computer science class, right? Like, wait, when am I ever going to use this join? Oh, wait, there you go, all the time. So,
all right. So windowing is, I guess it's definitely a thing in SQL and databases. I don't know how many other tools could do something similar. I'm sure there are equivalents because it's been so useful. And it's really, so back to the previous slide, one of the options or one of the fundamental techniques was just transforming data and aggregating. So that windowing is kind of a combination of the two. So you're taking, you're not reducing the number of results that you end up with. You are taking and creating a new field for every result. But how you calculate that field is, so in transforming, you calculate it based on the other information in that same event, same row, same line. But in the case of windowing, you're calculating that using an aggregate function, using some other data. So usually especially if you're working with time series data, you're doing a window of 30 days before to now. I want to know what the average was and put it in this. So again, you're not taking the whole data set and creating an average. You're taking, you can possibly like split it up too. Say the average number of connections to the domain that's in the current row that we're processing over the last 30 days. So, something like that. So it's kind of a more advanced concept, but it's just surprising how common and useful it's become.
And again, some of these things you probably have in your sim and you don't really realize, or you haven't realized at this point, that it's like something that is if you take a step back and look at it, like a technique that could be applied, even at the command line in some cases. And that's what we're going to talk about now, is the command line. Now, specifically, I'm talking about the Linux command line. And for illustration of, we think back to that data funnel. There'll be a couple of times where we say, think back to that data funnel, right? So this example kind of walks through some log file analysis of some Zeek data and kind of building those pipelines along, down that data file. But again, most people start at the Linux command line, at least in my opinion, to do some of these log file parsings. Now, that's not to say that you can't use PowerShell as well. I just happen to think that the Linux command line is easier to kind of get started with and kind of think through, because it processes data in a stream of text. And in fact, you have to use text. Your log files have to be text-based in most circumstances for command line for Linux. It's not to say that PowerShell is a bad choice. It certainly is. I think it's a great way to parse log files. I just really suck at it, so it's not my go-to dance move. But PowerShell is different in that it typically handles like the text as an object, and I've never stepped out of my comfort zone to learn PowerShell.
It's funny that you keep mentioning PowerShell and you even mentioned the object nature, because I think the strength that makes the Linux command line easier to work your head around and learn is one of the shortcomings we point out later. And having objects be a first-class citizen and native to the command line in as it is in PowerShell is kind of one of the ways to overcome that, but it does introduce complexity.
So a deep rabbit hole for sure. And so some of the basic commands that I use all the time, cat to concatenate data out to the standard out, or as you'll see with Zeek, since they're gzip compressed, Linux has a tool for everything. You can use zcat to decompress the gzip file. grep, which is going to be, so we're talking about filtering earlier, so you'll search for with grep, or in the case of gzip, you could use zgrep. There's always another command in Linux. There's always a different way to do it in Linux.
Yeah.
And I'm going to point that out again in a second.
There's a thing called the bash goal, where you try to do the thing in the fewest amount of characters as possible.
Yeah, right.
It's just, yeah.
And then another tool I use very frequently, cut, to cut out in delimited files, like called comma delimited or tab delimited files. You can filter further down specific columns of data, so to speak. So you can, get specific things out. Zeek cut is the if you've ever used Zeek, is specific to Zeek, and it'll pull out data based on the header or the column of the data. And then for transforms, I like TR. There's definitely other ways to do it. Sed, awk. But TR is pretty user friendly. And so the examples I'm getting ready to show, is there a more elegant and efficient way to do it? Absolutely. So when you make the comment in the chat, well, you could have done it this way. Yeah, I know. And so what we're doing is we're illustrating illustrating following that data funnel, like how you go about building the command line out. And then we'll show you the more efficient way to do it, or another efficient way to do it. And I made an analogy the other day, and I'm sorry if it's not exactly accurate, and you can stop me if you don't want to hear the analogy, but I looked at it kind of like calculus and pre-calculus, right? So I think that, this example is sort of the pre-calculus to the calculus, where, you need to find the area under the curve in pre-calculus. So you draw a bunch of rectangles under the curve and calculate the area using geometry. And then you have these little weird triangles with the curve still there. You have to calculate that area. And you're sitting there doing this in pre-calculus going, man, this is really tedious. I hate this. And then you get to calculus and they're like, hey, let me show you about this derivative. And what about this integral? And you're like, oh man, you could have just led with that, right? But then you wouldn't know you wouldn't know the hard way. And you have to know the hard way, right? You have to know the long way. And so in this example, what we're going to do is an incident response example. So we have a bad known domain. So two domains that we suspect are bad. And what we want to do, what management is asking, is they want to know, was any data exfiltrated? Because we're sure that command and control was established to these two CloudFront domains. And so can you tell me, was their data exfiltrated? So what we're going to do, start with that domain. We're going to filter the DNS logs and look for the IP address that has the answers to that domain lookup. And then we're going to pivot over to the connection log and find bytes sent and received. And once we get to the end of that, Ethan's going to show an easier way to do it. And so you can see in my first command here, I start out with catting out all the data. So we have all that normally produced data in the SSL log in Zeek. And I then use cut or Zeek cut to just cut out the server name, sort it, count the unique ones, and then sort it descending. So this is a data stack of the domains that were in this specific log file and how frequently they occurred.
You told me this is an example of data stacking, right?
Exactly. This is a data stack example at the command line of the server name for every SSL connection in the SSL Zeek log for that timestamp. And so what we do is we take those domains, these CloudFront domains here separated by a pipe, and we're going to pivot to the DNS log entry, and we're going to look for both the query and the answer fields that contain these two domains. And so we find that there are some domains that are associated with this. Now, back to that, comment about manual kind of analysis, certainly you could manually copy and paste this and put it in a text file and get the control characters out, the dashes out, that kind of stuff. Totally is valid. I do that stuff a lot. But what if you had thousands of entries that were all interspersed? I mean, it might be a little bit better to do it at the command line to get it into a format that we like, that we can use to search. Now, this ends up getting ugly pretty quick, right? So we're doing the same kind of thing. We're looking at the DNS logs, we're getting the answers out, we're looking at them. And so if you look at the screenshot before, it's in this block of text right here. Now it's separated out by pipe characters, which I need to do a further search. And so we go through, we cut out data, we do some transforms. This is kind of ugly. We're taking out new lines, we're putting in new lines, we're going to sort and unique, we're going to transform again. And we end up with the ability to search through the connection log. And so the output of that previous command gets put in here, where we have the IP addresses that were associated with the domain lookups. Now we want to know if those IP addresses in the connection log for Zeek had data that was exfiltrated. Now, usually what I do at this point is I ask the class questions about this, but since this is a webinar and you can't answer me, then I'll just go ahead and say that this is definitely beaconing activity. This is in bytes. So for every request, we have, 6,000 bytes that was received or sent to the 800 byte request. We have one that's a little bigger, that's 270K. But normally what I ask is, does this look like data exfiltration? And the answer is no, this looks like beaconing activity just based on the size. How do I know that? That's where that domain knowledge comes into play. I've seen it and I know. And so that's, my answer is no, this is beaconing. I also did the lab, so I knew that. But and so how can you slice and dice logs in a more efficient way?
So actually, can you go back a couple slides? I just want to do some unscripted, so give some people some tips. Yeah, so when you get command line looking like this, pretty hairy. So, okay, first of all, back up. I think we kind of forgot to talk about, for those unfamiliar with the Linux command line, it's a pipeline. So you start with data over here, and then you're literally using the pipe character, and it gets passed to the next command, and then that command does stuff to it. You do pipe character and then pass to the next one, and on and on and on. So you're starting out with data and it's getting passed along the shell pipeline here. When you get something really long like this, you might know what data is going into your pipeline, and you can see what data is coming out, and it might not look like what you want it to look like. You're playing a game of telephone with yourself and it's just not working. So some tips for developing this type of thing is, obviously do it a little bit at a time. Build your pipeline up. Like, you don't start with this. You start one step at a time. And if you're debugging something like this, or maybe working on, someone else's command, like Derek gives you this command and it doesn't quite work for you and you're wondering why. So in between the pipes, especially if you're working with a lot of data, head is a very useful command because it limits the number of results you get to 10. And so you just get kind of a sample of what you're doing. It doesn't take nearly as long as if you're waiting 3 minutes or whatever for your command to finish on all your data and only to find out it's wrong. The
Sounds like
Yeah,
you've
the
been
other
there
one,
before.
yeah, yes, definitely. Yeah, the other one, I guess it's just back to, hey, build it up a little bit at a time. So take out
Yeah.
take out pieces from the end, make sure the data is looking like what you expect, what you want it to do at every single step before you move on.
And that's actually that's a really good point, and that's why I build things out like this. I do know that I don't have to cat and then cut or cat and then grep, but I just the way I build it out in my mind, and sometimes like Ethan was saying, sometimes I'll find a command that's gnarly that someone else did and it doesn't work. I'll just start taking things off the end, and I like to look at it as that kind of pipeline. It's just how I do it. Doesn't mean it's right or wrong. It's just a way.
Yeah. So threat hunting toolkit, you can think about it as a toolkit, like a grab bag, like a worker's toolbox that has a bunch of stuff in it already. Really, it's just a neat way to package all those tools together in a familiar environment. So when you are in the threat hunting toolkit, you're in a shell, you're in Linux. It's all the same stuff that Derek talked about applies. You could use those exact same commands in the threat hunting toolkit. Where THT helps is, as we talked about at the beginning, we both done a lot of log analysis, and I was finding common patterns that I was doing over and over and over again. And it was just, I got tired of typing it,
Tired of
honestly.
typing
Yeah,
sort
yeah,
pipe,
yeah.
sort, yeah, or unique dash
Right.
C pipe,
So
sort NR, or sort.
what started out as a couple like helpful aliases ended up being this whole toolkit of scripts and other tools, like maybe, hey,
Miller.
Linux comes with, your hammer, your screwdriver, maybe a saw, but it's just basic tools. I find that there's a lot of power tools out there that sure are helpful. So instead of having at every new job site I was at having to go buy a new power tool, I just bring them with me. Yeah. So some of the benefits, right off the bat, like filter is the best one that I always start with. So like I said, this might look weird, because it's tools that are specific in THD, but you can use the exact same tools you were using before. Just throw in something new that will help. So the advice I give to people starting out THD is learn what filter is used for, and it's really a combination of find and grep. But the grep it's using uses multiple cores. You could do that with vanilla grep, but it
The
involves
rep?
some it's actually ugrep on the back end.
No,
So
yeah,
yeah,
rep.
it'll process files in parallel.
Wonder how
Uh,
many greps there actually are in Linux.
there's quite a
There's
few.
quite a few.
Yeah, and these aren't built in, the ones that we're talking about, but so grep will only search a single file, use a single core. So if you ever look at htop or your process utilization, your CPU utilization while you're running a grep, you'll see like one core is pegged, and you've got all these other 7, 8, 15, whatever cores sitting there not doing anything. Filter will help solve that. Like it will use all the cores for all the searching, and it scales. It's a lot faster, and it's a lot easier to type, in a lot of cases. So yeah, so we're doing the exact same thing here. It's shorter. Hey, we're taking all the SSO logs. We are pulling out the server name using a tool called Chop, which is just a way, instead of so Zcup is great, and I would use that, except it doesn't work with JSON logs. Or if you're working with not Zeek logs, just TSV log, CSV logs, or whatever. Zcut is very specific to Zeek logs. Chop is more generic. It can handle Zeek logs, generic TSV logs, CSV logs, JSON logs, etc. And then what Derek's doing on the end, sort, unique, sort, do it all the time. It's stack counting, right? And one of the terms I mentioned earlier is most frequent occurrence. And so that's what the last tool we see here is MFO, so most frequent occurrence. And then you can optionally give it a number to just, hey, give me the first 10.
Instead of doing pipe head,
Right.
pipe head dash and 10, right? So
Yep. All right, so moving on, just again, taking the examples that we've shown before and showing you different ways to do it using some of the convenience features in THT. So instead of instead of crafting, let's see, what are we doing here? We're getting those same IPs out. So we're filtering the DNS logs and we're looking for those two domains that we pulled out in the last example. And then we're again pulling out query and answers. And Derek actually didn't do this, but another way to just kind of condense the logs he could have piped to sort and unique just to get all the unique lines. And there weren't that many to begin with, but if you
Yeah,
have a lot of lines and there's a lot of duplicates, you might want to just show me the different ones. Show me the ones that are unique. So that's what the distinct script will do. And it's the same as piping to sort and unique.
definitely I do stage data for sure, especially like when you get into situations where your command takes a bit to finish. It is annoying to run a command that takes 5 minutes to run, and then you get the output and you're like, that is just not quite right. And then yeah, so staging the data can be useful for sure.
So I want to point out a trick in the last command, the last line in the slide. So filter-p IPv4. So filter, I mentioned, is kind of a combination of find and grep, but it has some other neat features. And like, it's got some preset regexes that I was using all the time. So it's got a regex that detects IPv4. And anyone who knows regexes is they're never going to be perfect, but it does the job pretty well. And then the -o flag is, hey, just give me the matches. And it's going to print them out one line at a time. So basically taking Derek's big long cut, translate, whatever, and condensing it into that. Like, hey, give me all the unique IP addresses. All right, so next slide, again, just same kind of thing. We wrote those IPs to a staging file, and instead of having them on the command line, you could combine command lines. We could do all of this, all of these slides into a single one-liner, but
then it'd be hard
why
to
do that to yourself?
Yeah, well, it'd be hard to talk through like the thing, right? So this is why I say yours is the integral to my pre-calculus, right? Like it's just a more elegant solution and way to get to the same kind of answer. And as you do more and more data analysis, having shortcuts is very beneficial.
All
and
right,
then
so this
you
is
actually do even more.
Yeah, this is taking it one step further. So this is one of those power tools that we mentioned. So ZQ, it's the Z project. I'll post it. It's code right now. So basically has a domain specific language where you can do things like aggregates. There's another one called Miller, which I use quite a bit. The cool thing about ZQ is it also understands Zeek TSV files, but it can also read JSON, CSV, TSV, whatever. As Derek mentioned, you could do the same thing a bunch of different ways. We could use awk for this. We could use an awk script. There's other tools like data mash would do this. There's a lot of different ways. Just this is one way you can do it, and it's included in THT. So yeah, basically taking all those individual byte results and we're summing them up based on the source and destination IP. So we're getting every unique source IP, every unique destination IP, and then the sum of the bytes sent and received. So Derek's point, when you see them individually, you can kind of look and see patterns and say, oh, hey, this looks like beaconing. This doesn't look like, there's a lot of data being exfiltrated. But seeing the summary is also great too, knowing like, okay, overall, what is it? 690K data
690K,
was actually
that was what the
downloaded.
responses were. So even smaller upload size. So this does not look like the shape of data exfiltration, right?
Right. Yep. Yeah. We'll see another useful metric for data exfil later.
So, some of the weaknesses of the command line, I love the command line, but, it's there. It's really powerful. You can build out very sophisticated commands, but it has limitations for sure. And probably the biggest one is, in my opinion, is the operating on binary type formats, right? Like it has to be text based, which is okay in most scenarios until it's not, right?
Mhm.
Like limited visuals, it's hard to do. Even if you do visualization at the command line, your mileage may vary and what that actually looks like. And human beings do well at looking at graphs and pointing out and being able to look at patterns in a condensed kind of way. And then there's no real structured data. It's all, like we said, just text and strings. And there's another problem. It's not a command line problem. For the rest of the talk, we're going to talk about how we saw some really big problems at Black Shoals in terms of our SOC.
Mhm.
And that is the amount of data that is coming in. So in our SOC at BHIS, we put in network sensors at all of our customer sites. And so, which is a great thing. I don't know other SOCs that do that. There may be, but there's lots of reasons why not. And Ethan, I think the biggest reason is how much data you actually end up with. So what is this, a 2-week calculation? How much?
Yeah, it's roughly 2 weeks of Zeek logs coming in.
Yeah, so we had
Wait,
42 sensors at the moment, I think, give or take, and over that, 15 terabytes of Zeek data over a 2-week period. And well, yeah, that's tough to do at the command line. And then on top of that, separation of organizations, normalizing log files. These are all things that you kind of have to graduate to the next step in your data addiction to kind of get out of, right? And so how do you solve some of those problems? Those are hard problems to solve. You start with the format.
all right. So up until now, we talked about kind of the strengths of CLI being, hey, everything is a string, and it's also a weakness. But the text-based formats that we're all kind of familiar with, CSV, TSV, JSON, XML, syslog. What was it that you called syslog there? Human readable log
Human
format?
readable. Same thing
Yeah,
with like ASA logs. They're a pain in the butt, right? And the reason
yeah.
why, like with syslog, is there's some what do you want to call them, like mutable fields or whatever. They get basically the same every time, like time,
Hmm.
date, log type, area, facility, that kind of stuff. And then you usually have a message that is a variable length message after
Hmm.
that. And I find that same thing with ASA logs, and there have been other log formats. It's easy to read as a human, and it's difficult to programmatically parse at the command line.
All right. So we kind of realized that this there, there there might be a better way. CSV is ubiquitous; it's everywhere. Basically anything that you have, if it's in a different format, there's a converter written to convert it to CSV. But there's problems parsing CSVs. They're not particularly storage efficient. They're definitely not query efficient. You got to go through the whole shebang if you want to search it. So there's a format out there that maybe isn't as well known. It's called Parquet. I want to say it's ubiquitous in the data science field, because pretty much every tool that is a data science tool is going to understand Parquet. So you can think of it like the CSV of data science, although CSV is the
I like
CSV of
that.
data science as well.
Yes.
um, but yeah, so Parquet is it's a way more efficient storage format. It's an efficient query format because of the way that the data is laid out. And we kind of realized this. I don't know this for a fact, but Derek's like, hey, there's some Parquet flooring. I wonder if that's where they got the name. I was
It
like,
has
no,
to be.
it can't be related to flooring. And then I looked at a picture. I'm like, oh, huh, that kind of illustrates how the data is laid out in the format. So that probably is how it got the name.
It's it's
It's
either
it's
that or
a
it's the butter from the 80s, and I don't get it then.
Yeah, it's
Well,
so Parquet is a hybrid columnar format. I think they call it, but basically it's got rows, right, it's got chunks of columns. We'll say so it's stored like the columns. So same like all the timestamps are stored together in the file, and then all the IPs are stored together in the file, um, but in chunks. So they're like maybe a chunk of 100,000 is stored and then you get the rest of the columns, and then another chunk of 100,000 timestamps. So like, yeah, the alternating rows and column chunks is a pretty good analogy there. So anyway, the little tiny graphic there. So if you remember, the last one was 15 terabytes. So I've been making an effort to convert that same that same data to Parquet format, and Parquet supports compression as well. So after the conversion, it was down to 4 terabytes, which is still a lot of data, but it's a lot more efficient query format.
The third reduction. Well, more than a third.
Yeah. Oh, the other thing about Parquet, so it has like kind of summaries or almost database-like indexes. It's not a full database, but it's got, hey, this chunk, here was the max value, here's the min value. So then if something goes and reads the Parquet file, like here's a bunch of things that support Parquet, maybe you've heard of some of them, like pandas, and some of these might be more unfamiliar. They can go and look at your query and look at the metadata in the Parquet file and say, oh, these chunks, I've got the min and max. It doesn't overlap with what the query wants. So I'm just going to not read those at all. So it can go and like strategically pick out from the file, data that could be relevant. So it's searching a lot smaller subset, plus it's more efficiently stored and yada, yada, yada. So we find that Parquet is really great combined with S3 storage. So there was some discussion in Discord earlier about SIMs being too expensive, and another point of, hey, SIMs are actually more affordable than ever before. And I agree with both of those, honestly. I think the key piece is, yeah, SIMs are more affordable, but that just means we can shove more data in them, and we're not running out of data.
Yeah, so I mean, it is that way for sure, but I mean, it's always it's cost benefit analysis, right? We have 15 terabytes every 2 weeks of Zeek logs. We could shove that in the SIM and pay for storage twice, right? I mean,
pretty much, yeah. All right, so once you have your data on S3, it's kind of the gateway drug to a distributed cluster, because that's a pretty good way to
operate on the data.
It's a pretty good architecture. That's where a lot of these projects are going these days. So yeah, let's talk about speed. We can actually speed through these slides. Back to our data funnel. Parquet just helps us do broad strokes, and just back to, hey, you don't have to just apply the funnel once. Do it again and again, as much as you can. So filter out as much data at the beginning as possible. And something like hide partitioning helps with that. Basically, it's just a fancy way to name your files and organize your files so that your query can look at the paths that your file is stored at and be like, oh, this path only contains data for this month, and your query wants something 3 months ago. Like, I don't have to look at anything under that path. That's essentially hide partitioning. So limiting the time range is a good thing. Like, yeah, if you've got data back to 3 years or whatever, you probably don't always need to query all of it. Decide, what's most relevant to you, and focus on that time range. And we did this earlier with writing our results out to a temporary file on the command line, but caching results into a smaller data set. So like you decide, okay, this is the subset of data that I want, but I don't necessarily know what all I want to do with it. So grab that subset of data, store it somewhere, and now you've got a much smaller set of data to work with, and you can do experiments much faster that way.
Just sometimes behind the scenes what's happening in your sim, right? You just don't know that.
Yeah, totally. Caching, especially if you're running the same query over and over again, chances are the sim might be caching those results for a little bit. Okay, so lazy evaluation is pretty cool, honestly. So some of the technologies we had on our previous slides, Spark, and I think Pandas can do it now, Polars can do it. Basically, if you line out, hey, this is my data pipeline. This is everything I want to go from like ingest to this is my result. Instead of executing it like one by one, like you might do from the command line, say, I'm going to run this command and then this command. if a query optimizer, like in a database, can see your whole command, your whole query, your whole pipeline at once, it can say, oh, I see that at the beginning, he's selecting all the fields and say like, he wants all the fields because obviously doesn't know what he's going to end up with, or what he or she is going to end up with. But at the end and in the middle, he only uses these 3 or 4 fields. So the query optimizer can actually go back to the beginning step and only pull the fields that are actually used from the data in the first place. And there's a bunch of things that it can optimize away like that. Say you do 2 steps that make sense for you to think through, but they aren't the most efficient way for it to execute. A lot of query optimizers can detect things like that and combine them into a more efficient way. So you get readable steps and queries, but yet it's not inefficient like you wrote it.
Yeah, I mean, the lazy evaluation and caching thing is basically how the big data internet works now, like with PySpark and Spark type stuff. So we ended up having to solve for scale for Zeek data and our SOC, and the reason why is because you have 10, 20, 30, 40 sensors, and they're all not part of the same cluster. Like it's very difficult for analysts to kind of keep that straight, right? Like, well, okay, I need this customer go to these couple of sensors and look, and so basically what we ended up doing was treating Ansible to run THT scripts across all of our sensors and then bring back the log data, which is perfectly fine, but still might have scaling issues. And it is a Rube Goldberg machine of not to take anything away from the whole thing. I mean, it's how we solved for it at one point, right? And still what we kind of do now, but I'll let Ethan talk about what we want to do looking forward, because I don't want to misspeak on.
Oh no, sorry. Yeah, so we still use the duct tape popsicle sticks, Ansible.
Well, all of it is duct tape and popsicle sticks.
Yeah, we have the series, like we saw the screenshot of the 42 droplets just sitting there. We might as well use them as kind of a poor man's cluster. So, but the other things that we're looking for is, so I really like ClickHouse. I've been playing with that a lot lately. So it's a columnar database, OLAP database. So it's meant for analytical querying. And it just has a lot of efficiencies for the types of workloads that we are doing. So right now, like we're shipping all our data into a ClickHouse database, and Grafana has been a great tool for visualizing that data.
What can we do with all this data?
Yeah. So here's a couple examples of things that we can pull out. So these are just summaries. Like we're playing around with dashboards and like what might be interesting. So this is really easy to detect visually, an IP range scan. So you see the spikes there going up, like that's how many distinct IPs are being communicated with. Not number of connections, just distinct IPs. So that's, someone's scanning a broad swath of IPs and that happens to be internal IPs. So it's probably an internal either asset inventory system or a vulnerability scanner.
And then pretty nifty to detect a port scan and all that data.
Yeah, and down in the bottom one is a same thing, but with a port scan. So you can see the spike goes up to 65,535, and that's all the ports. Like someone's scanning all the ports. A smaller spike would be like, oh, maybe they're doing 1,000 port scan or whatever, but that's what they look like.
We can do fancier things too, like producer-consumer relationships or producer-consumer ratio. So real quick, we have 2 minutes, right? We're not even going to get to the bonus slides. Well, maybe
that's why they're in the slide deck for people to download.
So real quick, PCR ratio, you're basically calculating a ratio of bytes sent versus bytes received. There's the algorithm for it. It's pretty simple. And the idea being is that you're trying to look for a fluctuation in the ratio where 1 is a pure push from a host event upload and a -1 is a pure download. And so, yeah, if you're just downloading stuff normal user behavior, you might not, you won't, get like the spikes that we see here based on the ratio.
Yeah. So these graphs take a little. There's a little more going on, but basically, yellow and green lines, which are kind of hard to tell apart, but they're the solid lines here, are bytes in and bytes out. So sent and received, and then the blue line is the PCR ratio, the blue dotted line. So the blue line when it goes up means that there's an upload happening, but like the ratio is it's a pure push. Like there's not a whole lot of corresponding download happening. And if it goes down, that means there's a download happening. There's not a whole lot of bytes being sent upload wise. So the first graph is an example of, hey, there's a spike in data. I wonder if it means data exfiltration. But if you enrich that data with the PCR and you see that PCR is kind of flat, like, no, they're both increasing lockstep or like in the same ratio. So the PCR stays flat, and it's a good way to tell, that it's not really concerning. Versus the bottom graph, we've got a spike, and it's also combined with a shift from the PCR from download to upload. So this could be data exfiltration, and in this case, I'd want to like widen out the view and see, is this pattern common in this organization, or is this something that we need to look at?
So I think we made it right at 2 o'clock for the conclusion. And someone asked if we could talk about log file analysis for an hour, and I chuckled and said we could probably go for quite a while, actually. And so I personally think that the fundamental stuff that we showed at the beginning is probably these are still sets that we should work every security practitioner should be able, at least familiar with what can happen at the command line. And if you're doing that type of work, like the command line is kind of where you start. And then as you move forward, well, you might have bigger problems to solve.